These methods can help identify the effect of the molecular structure of electroactive organic molecules on charge carrier generation and dynamics, ionization potential, electron affinity, and band gap values.
These methods are a cheap and fast way to determine the most valuable parameters for many electroactive materials without the need to construct special devices.
The presented method can be used to analyze all types of electron-active compounds, such as those with delocalized pi electrons, including small molecules and large polymeric chains.
To begin the CV procedure, fill a clean electrochemical cell with 1.5 milliliters of electrolyte solution and cap the cell with polytetrafluoroethylene electrode holder. Insert working auxiliary and reference electrodes into the cap, with the working and reference electrodes as close together as possible without touching. Ensure that the electrodes are immersed in the electrolyte. Then connect the electrodes to a potentiostat, being careful not to let the connectors touch each other. For a reduction analysis, bubble inert gas through the solution for at least 5 minutes to remove dissolved oxygen. Then, raise the inert gas line above the solution and leave the gas flowing throughout the experiment. Once the electrochemical cell is ready, open the potentiostat software and select the CV procedure. Set the start potential to 0 volts and set the upper and lower vertex potentials to